Hello, welcome to a new video. So in this video we will be discussing about MongoDB and how we can optimize the performance of your query. So we will be basically covering sharding. So before going into like sharding, we should know about why we use sharding. So for optimization of the our database query, we will be going for the sharding. So there could be more other way for like improving your database queries. So the first and the most common thing that you might have used is indexing. So you index your queries, and index should be done smartly. Otherwise it also creates overload on write operations. Let's say uh, you had created some index on email, and uh, let's say I would say uh, okay, so let's say you have email field, and let's say name field, let's say age field, and you want to log in, and you have index on age and email. So that is not good. So what we do, most of the time when we are logging through the email ID. Okay, so we should just index email, and it will create a new data structure that is like a B tree. And what it do, it will store your data in tree like structure. So you do not need to like every time search your document. Okay, instead it will be searching into this tree like data structure, and you will be getting your data. So this will optimize your query, but yeah, it will add an overload because it is inserting into your DB also and into the B tree. So we had to like be smart while designing your index. Okay, then we can limit the fields. We do not like directly write db.find. uh, okay, so maybe let's wait. Okay, I don't know what happening. What is this? Not able to like change. Okay, so let me pick a pen, and then so we should be smart while writing your DB queries. Only project the values which you want in your queries. Okay, then pagination. Instead of querying for the complete data, we can go for the uh, pagination. Yes, one more thing, that is the dot explain method, and we pass execution instead. It will give you a result of whether whether this query is like call scan or index scan. So if it is call scan, then we need to optimize it to index scan. Okay, so we need to keep in mind all these things, and we should avoid n+1 queries. Okay, so let's say we want to like execute some queries where we want users to be like, let's say you want to find db.find db.users.find, and once you find the user, you want to run one more queries db.orders.find all the orders of this user. So there will be n orders, so that is not good thing. Instead you can use what we call aggregation. So aggregation basically do what it will aggregation do queries in phases. So let's say we have aggregation. So what it do, it will take phase 1, any query can be anything, and phase 2, and based on this they are making query over it. So if you you can go and check the documentation how this is this are done. And you can see here I am doing lookup. So it is looking into the uh, orders table and checking the local fields in orders, and then checking the foreign also, and then it is like what it to do. There would be like users, and inside that document a field will be inserted for the orders, and it contains the different orders of that user. So this basically avoid your n+1 queries and optimize your database. Other thing is use TTL. So let's say if you are storing sessions, let's say you are doing some verification password reset kind of things, then you can use TTL. And once that expiry time is complete, your token or your key that is stored for that time will be removed, because we do not need after that. Okay, so you can use that will also like, instead of storing, it will be cleaned automatically. Read replica sort. So before going to the sharding, we should like see these things will be implemented in your queries or not. And the most important thing is read replica. So by default, when you create MongoDB database and connect, then it will give you a replica set. So I had created something, yeah. So it will give you a primary database, primary, and there are two fail in condition of, let's say, failed, then you can like move to the different replica set. So this is also like important. So this is like how to we connect. And you can also mention your read preferences will be done from which replica. So this could be done also. And the other thing to avoid like overload on your database, let's say we have some profile, or let's say we have some dashboard kind of thing, and we are hitting your database every time. uh, once that also could be problem for your query. So we can introduce caching. Instead of hitting your database every time, it will cache your data, and it will increase your performance. And also in the last video we had discussed about the connection pooling. So let's say we have at same time we have 10 connections. So if 100 users send the request, and 100 queries goes onto the MongoDB, then 90 will be waiting in polling queue, and 10 will be getting executed. And once those execution complete, other are post. I had already discussed in like previous video, you can go and check. Then we our goal is to like achieve massive read and writes, no single point of failure. So this read replica is a good thing, that is like we have multiple replica of a database. So this handle the failover conditions and low latency. So low latency could be done through all these things, and easy scalability. So if we see when we need a sharding, so when we have like millions of records that could be impossible to store in single database, so we need to like scale horizontally. Let's say we have 100 GBs or TBs of data, and storing it and then executing query of on that big data is like very difficult, and it will like taking a lot of time. So in that scenario we need to like go for the sharding. Before that we should like keep monitoring your MongoDB and check for the queries and the graphs, how it is behaving on queries, and then only we can go for the sharding, because it will be adding a complexity to your queries and managing it. So if you talk about the simple replica set, so once you do your MongoDB query, it will go to the uh, Mongo will be routing those queries. Let's say if it is write, then it will go to the write replica, and let's say if it is for the read, then it will go for the read secondary replica. Okay, and you might have one more question. Let's say we had some query and it is like insert query, so it will go to the primary and data is inserted, but how the secondary got synced with the primary? So that is good question. So the MongoDB manages using oplog. So oplog is a internal function in MongoDB that will be creating a JSON file for the changes, and keep inserting those changes into those records, and those records are keep check into other replica set in background, and if there was some change, uh, it will like it will sync those data, but might be sometime it would take some time. So that could be concern if your system is like too much dependent on read and writes, and there could be some problem. So for that we can use we have some, while reading we can pass flag called read concern majority. So it will guarantee that the data is committed into your replica set, only then those queries will be fulfilled. Otherwise you might see some lag while saving if you do not read concern flag. So this is like internal working of how read replica and write replica are synced with the real data. Okay, now let's go to the sharding part. So let's say we have now millions of GBs of data. So how we can like distribute data and increase our performance? So let's say we have like 100 of GB, so we create shards and we choose a shard key. So shard key should be choose smartly, otherwise it will like not to be even distributed, and one shard will be like bombarded with more queries. So we need to be like smart with these shards. See here, there is a query router dot mongoose, which will be like routing your queries to different shards. This is also like in the replica set also. So this is the internal of Mongo. And then what we see, we have seen ride booking apps how big it's like, let's say Uber. So he need to maintain 100 and 1000 GBs of data. So maintaining those big data is like impossible for single database, because we are hitting hardware limits. Okay, QB, see, we cannot scale to trillions of data, so we need to like understand that part. So here we have chosen a shard key for city. So city 1, let's say data of city 1 will be stored on shard 1, data of city Mumbai will be shard 2. So once we like perform a query, and if 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 we see some query which is related to city ID, let's say for Delhi, then it will be go to that only side, and other side will be not touched. So this will be like distribute your database horizontally, and it will also like increase your performance of MongoDB queries. Okay, so we can have to like smart with choosing your sharded key. So in e-commerce website, or let's say in Rightbo website, we can use based on the region, from region where we are like trying to execute your data. So let's say if a user try to execute some query from Delhi, then will be started to the Delhi database. So this will also optimize your data. And yeah, I will share you this document, and if you have anything to discuss, we can discuss on it in comments as well. And in next video I will be explaining you about the MongoDB query, like explain lookups, and most of the part will be revolving around aggregation things, and will provide you some resources. Well, then you can read about Mongoose. Mongoose is a ODM for MongoDB, so you can read it about it. And yeah, thank you for this watching it.